Hello, my name is Nathaniel Rubin, and today we will talk about Perl. Last year, I presented a talk named The Perl Jam at 31C3 in Hamburg. In that talk, I pointed out several non-intuitive features of the Perl language and how an attacker could exploit them. Unfortunately, rather than fixing the issues, the Perl community decided to reject my talk. So it was clear I had to give another talk. This is why I'm proud to present Perl Jam 2, The Camel Strikes Back. All right, so you may ask yourselves, why should anyone even talk about Perl? Isn't it dead already? Well, surprisingly, Perl is still the top 9th language being used today, mainly because your legacy systems use it, some of which are even accessible through the internet. Now, let me ask you a question. Have you read this book? Well, obviously not, because this book cover is just a joke. But it is common knowledge that Perl code is quite difficult to read. And when code is this hard to maintain, vulnerabilities are just waiting to be exploited. So in the previous talk, the one I gave at CCC, I explained how Perl's lists are actually expressions, used in many confusing ways. I also showed CGI parameter can create lists using regular user input. But most importantly, I showed that when the two combine, problems happen. Now, the real interesting part is how the Perl monks responded to that talk. Now, the main discussion took place in a Perl monks forum thread that began with the claim, "Sad news from Germany." A bit dramatic, but okay. After a long discussion, they came to the unavoidable conclusion that the talk was, in fact, a polemic shit, and they should all just piss on it. Wink. Later, they realized I'm just a script kiddie preaching to other script kiddies, and not just any script kiddies. In their eyes, the entire audience was a heterogeneous group of chaotic punks who loved to see themselves in the hacker image of Hollywood media. Kind of hardcore. So as the discussion continued, it just got more and more ridiculous, as they even went as far as criticizing the crude use of propaganda in the Camel images. At that point, I started realizing the Perl community didn't like my talk. The unfortunate part is that they completely ignored all the valid technical points because of some camels and funny images, using many lame excuses. 2 of these lame excuses has been repeated over and over again. The first excuse was that I should read the manual, which is weird because I thought I was the only one who did. And the second is that I was talking about old Perl and not the new modern Perl. Keep these points in mind as I'll break them later in the presentation. But enough with the intro, let's dive into the new madness. Now, Perl is weak-typed, meaning it allows declaring variables without specifying their data types. Of course, this functionality exists in many dynamic languages and is completely fine and very convenient. But, as usual, Perl took it to a whole different level. Perl went as far as removing data types declarations from function arguments. You can see in this pseudocode, I'm just receiving 2 different arguments without knowing what type they are. Let me be clear about that. You don't get to choose whether you want to specify argument data types or not. You can't specify what data types you're expecting to get. So even if I've built a function that only works with strings, I have no way of forcing that at the function declaration. Now that is annoying. The real kicker is how this feature is used. Apparently, it is very common to write two completely different blocks of code, one that handles scalar types like strings or ints, and one that handles non-scalar types like arrays or hashes. Let me repeat that. Writing multiple code for multiple data types in one function is a Perl standard. And that is just sad. You shouldn't write redundant code because the language lacks the capability of letting you decide which cases you don't want to handle. By the way, Python doesn't let you declare your function arguments data types too, but unlike Perl, writing redundant code to cover that up is definitely not the standard. Anyway, sad as this may be, this Perl convention is not dangerous. The dangerous part begins when hashes and arrays are considered as secure data types, mainly because they cannot be created by user input. This results in this kind of code, where if the function argument is a hash, for example, it is used unescaped in dangerous functions. Hashes specifically are considered so secure that even if you use taint mode, which is some kind of safe mode for Perl applications, hash keys are not tainted, meaning they can be used in dangerous functions without any validation, as opposed to any other data type. Now this code appears a lot in Perl code, and apart from the many bugs this method can cause, it also makes your code exploitable. So we know function arguments are of unknown data type, and we know developers treat hashes and arrays as secure data types, inserting their values into dangerous functions unescaped. But these practices isn't something that was created a long time ago and found only on redundant code. Because of how the language is built, it's supposedly restrictionless type of developing. Even now, it is the natural way to code when you're using Perl. So even if you learn Perl today, which I'm really hoping you won't, you'll probably use this kind of coding standards. But for now, all we know is that if we'll somehow manage to create these secure data types with our user input, we could exploit the code. So the only question remaining is, what are we gonna exploit? Bugzilla. Like every other Perl project, Bugzilla is heavily using functions that treat scalar and non-scalar argument types very differently. And this is one of them. The load from DB function is responsible for extracting object-specific data out of the database. Like I just said, it treats scalars, and in this case hashes, very differently. If the function argument is a hash, it takes one of its values and inserts it as is, unescaped, into an SQL statement. Again, because hashes are considered secure, so there's no point of escaping them. On the other hand, if the argument is a scalar, it converts it into an integer and only then use it in an SQL statement. Because scalar values are not secure, so you have to escape them. This means that if we could control the function argument entirely, including its data type, we could control the SQL query, effectively exploiting an SQL injection attack by inserting a hash containing that specific value. But CGI input doesn't allow hashes, right? The whole Perl security module is built on that assumption. The problem is that, like us, developers are assuming CGI input is the only input method available, CGI. But CGI isn't the only way to go. Bugzilla developers miss the fact that their own system is also featuring an XML RPC and a JSON RPC, both supporting input of non-scalar data types like arrays and hashes. So if we'll use one of these RPCs, sending our input parameter with a malicious hash, instead of just a regular numeric parameter, we will be able to exploit the SQL injection. So if we'll send this regular request using the JSON RPC interface, the number 1 will be used as the ID of a bug to extract. But if we'll send this request where instead of an integer we'll supply a hash, then suddenly we will be able to inject any SQL we'd like into that statement, effectively compromising the entire database. And as we know, when a Bugzilla database is hacked, news stories are popping all over the world. So when you look at this request, you realize that this is not a sophisticated vulnerability. All I did was just change the input data type, and that's it. The system is compromised. It was so heavily built on the assumption that hashes are secure that it offered me almost unlimited access security-wise once I created it. The funny thing about that is that although it is so simple, this attack has existed for over 5 years now. So we now proved this unknown argument type feature is a huge source for problems. And we also know writing different code to handle different data types just causes a lot of false assumptions. But most importantly, treating non-scalar data types, such as hashes, as secure just because they supposedly can be created by the user is very, very bad. Just ask Bugzilla. But the shocking part really is that, again, this is the Perl standard. You are not expected to use it, you have to, as you don't have any other choice. This security mess is a fundamental part of the language. But the problem is that creating non-scalar data types is impossible in some cases. Well, we can't rely that some kind of RPC will exist in the code and support different data types. And we can create data types using regular user input. Right? Well, let's have a look at how the 3 most popular CGI modules handle different kind of input. First, we'll take the most trivial scenario. A single valued parameter, which in this example, the foo parameter is assigned a string bar. In this case, a scalar is created on all 3 modules, which doesn't really help us, but is pretty much what we've expected. But what happens if instead of sending a single valued parameter, we'll send a multi-valued parameter? Like in this request, where the foo parameter is now assigned 2 strings. Now, things are starting to get complicated. On CGI-PM, a list is created, which is very useful for us, but not what we're after. Let's have a look at what the new Perl modules are creating. We'll see that both of them are returning arrays containing our values. Arrays. What? I thought you can't create this kind of data types with regular user input. After all, they're considered safe. But let's continue. What happens if instead of sending a regular value, we'll try and upload a file? Now, things are really getting out of hand, because CGI-PM now returns a file descriptor and Catalyst Modulicious returns a hash. What? We just exploited the most popular Perl project in the world because they assumed hashes can't be created by the user. And now we're finding out that not only we can create hashes, it's a feature. Let's send a multi-file upload request. Watch closely, because this is where it gets ridiculous. Now, CGIPM returns a list of file descriptors, Catalyst returns a list of hashes, and Modulisys return an array of objects. What? Almost any Perl project in the world uses one of these modules for parsing CGI input. Just think how many developers assumed the exact same thing Bugzilla assumed and treated hashes and arrays as secure data types. So if you're using CGIPM, instead of the expected scalar value, you could be getting a list, a file descriptor, or a list of file descriptors. And if you're using Catalyst, you could receive a scalar, an array, a hash, or a list, which basically means any data type. So, expecting your function arguments to be of a specific data type is false. Expecting hashes and arrays to be secure is also false. And expecting scalar-only user input is a major false. And to be honest, it seems that in Perl, expecting is false. You just can't expect anything, even the most basic of things, such as what data type your variable is made of. You just don't know. But I felt all of these points will go unnoticed without an extreme example of Perl's absurdity. So I found an extreme example, one that will clearly show the ridiculous nature of the language. And this is it. All this code does is print an uploaded file's content. And to show you how basic and simple it is, I'll explain each line. The first line just creates a new CGI instance, so we could get the file from the user. The second line checks if a file has been uploaded in the file parameter. The third line gets the file descriptor from the CGI module, and the fourth line just loops through the file lines, printing them at line number 5. Again, all this code does is get a file and print it. That's it. A user has uploaded a file to the server, and the server is just returning its content. It's not saving it anywhere, it's not moving it anywhere, it just prints its content. There should be absolutely nothing dangerous in this code. It contains literally 5 lines, yet it's demo time. So for the demo, let me just duplicate my screen right here. Great. I know you can't see the text. Trust me, it's not needed. All you need to see is that I have 2 different requests here. I have a simple request or a normal request, and I have a malicious request. When I send my normal request to the server, nothing really happens. The server just prints my uploaded file content. But when I send my malicious request, watch closely. What was that? Shall we see it again? No. I see on this screen. So, right now, you are probably asking yourself, hold on, what did I just see? Was that a terminal screen? And the answer is yes. Specifically, the ipconfig command output. Or in other words, these 5 lines contained a remote code execution vulnerability. So now that you saw the magic happens, I think it's time for some explanations. The first line, responsible for checking if a file has been uploaded in the file parameter, doesn't exactly do as it says. Instead of checking if the file parameter is an uploaded file, it checks if one of its values is a file descriptor. Let me clarify that. Instead of checking if the parameter is only a file, it checks if the parameter is also a file, meaning that uploading a file and assigning another scalar value to the same parameter will still work and bypass the check. What? So now we can assign the file parameter both a regular file and a scalar value. But what happens when we try to get the file parameter value? Well, in a regular request, it will return the uploaded file descriptor. But now that we're adding another value to that parameter, param returns a list containing all the values we sent, the file we've uploaded, and our scalar value. But the file variable can't contain two values, right? So instead of converting the returned list into an array, Perl only uses the first element of that list. So if we'll send our scalar value before we send our file, the file variable will be assigned our scalar value instead the uploaded file descriptor, which means that now file is a regular string, not a file descriptor. But what happens to this operator when we use a string instead of a file descriptor? Basically, using a different data type. Well, obviously the brackets operator doesn't work with strings. Of course, why should it work with string? It works with file descriptor. It reads files, not strings. That appears true unless that string is argv. And in that case, the brackets operator loops through the script arguments, which in CGI comes directly from the query string instead of command line, and it treats them as file paths, inserting each one into an open call. What? How does that make any sense at any given point in time? All of this basically means that now, instead of displaying our own uploaded file content, we can display the content of any file on the server. But that's not the end, as we haven't executed code yet. To execute code, we have to look at the open function. Again, this is the function being called with the argv values as file paths. Open is responsible for opening a file descriptor to a given file, unless a pipe character is added to the end of the string, and in that case, instead of just opening the file, open will now execute it, basically acting as a regular execall. So, when we send our exploit containing the regular uploaded file, our argv malicious scalar value, and the ipconfig command followed by a pipe, this is what we receive: a proper remote command execution. What? But I'm not done yet. Truth be told, I didn't try that code. Remember that Perl monks told me that I should read the manual? Well, guess where that code came from? The official CGI documentation. Just think how many people have used this piece of code for their website. But I'm not blaming CGIPM developers, nor am I blaming developers who copied from CGIPM examples. How could anyone have known that this code could be exploited that way? There are no execalls. The file is not saved anywhere. Heck, the only function we are calling is print. The sole responsible for this mess is the Perl language. Perl is the one silently expanding lists. Perl is the one mixing up your data types. Perl is the one executing user input with no execalls. Perl is the problem. not its developers. But while a minority of the Perl community took my criticism and tried to suggest some improvements, most Perl monks thought otherwise. In a detailed blog post published in the official Perl blog, Joel Berger wrote his response for this presentation. According to him, Bugzilla developers simply write crappy code. Vulnerabilities in module documentation are kinda bad. And in general, it seems that again, the Perl community decided to ignore the obvious pitfalls in the language and just claim that if you fall in one, it's your fault. So while Perl is still used, at least to some extent, in websites such as IMDb, Craigslist, and even Amazon, its community blindly rejects any kind of external criticism. And that is the really sad thing here. How can the language improve if the community can't accept any external criticism? How can anything improve in these circumstances? How can you trust this language for your applications, knowing that even after Larry Wall, the creator of Perl, claimed that he wants Perl 6 to keep what works, fix what doesn't, and add what's missing, his own community declines doing just that. So sadly, until this language is fixed, the only thing you can do is stop using Perl, at least in a CGI environment. Thank you.